Okay, this is a continuation from the lesson about aerial photographs. Remember, I said I'm going to share aerial photographs, and also the orthophoto map. So this is an example of an orthophoto map. So what I'm going to do now is I'm going to explain now how do we come up with the orthophoto map and how is it also created. That's what I'm going to do. Okay, so an orthophoto is a combination of aerial photograph. It's a combination of aerial photograph, I'll just write it in shortcut, and topographical map. Topographical map. So when you talk about an orthophoto map, it's a combination of aerial photograph and topographical map. I think I've already explained what an aerial photograph is. Obviously, these are the photos that are taken from above the Earth's surface. We basically have the vertical aerial photograph, we have got the oblique aerial photograph, then we have got the horizontal aerial photograph as well. But our orthophoto now is a combination of aerial photograph and topographical map. But mostly we are looking at the vertical aerial photograph. Just to do a recap so that at least you can have an idea of what I am talking about, just in case you missed the first lesson. So when we are talking about vertical aerial photograph, we are now saying that this is where the position at which the photo is taken from. So this is from an aircraft or from an airplane. We are taking part of this Earth's surface. This is what is covered. We are taking part of this Earth's surface, which means from the 90 degrees vertical from the top. That is your vertical aerial photograph. But when you talk about an oblique now, we are now saying oblique, it simply means at an angle. It simply means at an angle, which means it can be at 60 degrees or it can be at 30 degrees. So these are angles at which the aerial photograph is taken from. So we have got the vertical, which is here. I'll just say vertical. Then we have got the oblique, which can be high or it can be low. So the high is at 60 degrees and the low is at 30 degrees. Then lastly, we have got the horizontal or the terrestrial that is taken from the Earth's surface. So whenever I talk about the aerial photographs, basically that's what I'll be referring to. But our orthophoto now is a combination of aerial photograph and topographic map. This is what makes up the orthophoto. But mostly I'll be looking at what you call the vertical aerial photograph. So an orthophoto is a combination of vertical aerial photograph and topographical map. I'm just going to take you through some of the basic features or information that you can have on an orthophoto map. So this is our orthophoto map. You can see this is our orthophoto map. This is our orthophoto map. You can see where it's starting. Part of this is an orthophoto map. This is what we call an orthophoto, and we have said that is a combination of vertical aerial photograph and a topographical map. How have they made or come up with this orthophoto map? They use the process of what we call data layering, which means they put information on top of each other. It starts off as an image, then from that image they went on to add the drainage system. You can see the drainage system, you can see the rivers that are on this photograph. You can also see they went on to add also the contour lines, which also shows the topography of an area. You can see Maiden Castle, you can see the contour lines and everything. So it's an image that has information that has been put on top of it. That's what we refer to as data layering, which is a GIS process. So the orthophoto is a combination of vertical aerial photograph and the topographical map, and it is made through the process of data layering, which is a GIS process. So it means from this photograph, they have gone on to add on the built-up areas. You can see they've gone on to add on the topography, which is part of your contour lines. You can see we have got contour lines here. You can also see that we have got spot heights. You can also see that there is a drainage system which shows the rivers like the Clip River. You can see that is passing through the area. So all these have been combined. Of course, the data has been added on top of each other just to come up with what we call the orthophoto map through the process of data layering. So we started off by having a photograph, and on top of that photograph, they've added some other data layers to come up with what we call an orthophoto map. So an orthophoto map, I'm just going to do also, and just to add on more information so that you can have a better comprehension of what you can find on an orthophoto map. The first thing that you can find on an orthophoto map is your scale. This is your scale. You have to make sure that you know the scale of an orthophoto map, which is 1:10,000. Okay, this is in centimeters. It means that 1 centimeter on the map represents 10,000 centimeters on the actual ground. That's what this map shows. Okay, this is a type of a ratio scale. This is a type of a ratio scale. But I always encourage that whenever we talk about the scale of a map, try by all means to convert it to different units so that even if it comes that on one of your assessment written in another unit, you'll be able to know the exact answer. So you can actually convert this into meters, which means it becomes 1:100 meters. How did we get the 100 meters? We have just looked at how many centimeters are in 1 meter, and we said it's 100 centimeters. So it means we simply divide here. Then that's how we get the 100 meters. We can actually convert it as well into kilometers, which is 1:0.1 kilometers. How do we get the 0.1 kilometer? Okay, we just divided by 100,000 because in a kilometer there is 100,000 centimeters. So you are supposed to familiarize yourself with this scale of an orthophoto map, which is 1:10,000, 1:100, that is in meters, 1:0.1 kilometers. This unit is not changing. It remains in centimeter, which means 1 centimeter on the map, 1 centimeter on the map, 1 centimeter on the map. What is only changing is here. We have got here 1 centimeter on the map represent 10,000 centimeters on the actual ground. 1 centimeter on the map represent 100 meters on the actual ground. 1 centimeter on the map represents 0.1 kilometers on the actual ground. So what is only changing is what is on our right side. What is on our left side is not changed, which means this one remains the 1 centimeter that we are talking about. So that's one of the things that you're supposed to know when it comes to your orthophoto map. That's number one. Number two, you are usually asked in terms of, there can be a question in one of your test or exam that asks you about the contour interval of an orthophoto map, which means you need to familiarize yourself also with the contour interval of an orthophoto map, which is 5 meters, which means when you are looking now at this map, you can see this is made in Castle, this is 1,090 from there, there's 1,085, which means the difference in height between these two contours is 5 meters. From 1,085 to 1,080, which means the difference in height between two contours is 5 meters. That's what this simply means. So that's one thing that you're also supposed to familiarize yourself with. Then the other thing, they can ask you, how is height shown on an orthophoto map? So you need also to know that it's shown in terms of the contour lines, because you can see that this is the peak or the highest height of your mountain castle, which is 1,092. But as you go down with the contour interval, you can see at the bottom or the foot of the mountain is around 115. So you are able to know the height on an orthophoto map by simply looking at the contour lines. So the contour lines are also used to show height on a orthophoto map. You can also check on your map. You can see there's a spot height here, 1,001. There's a dot, then 1,001. This is another way in which height is shown on an orthophoto map. The other way, okay, still on the orthophoto map, this is also your spot height, as you can see here, 998. So these are the different ways in which your height is shown on orthophoto map. You can see also here there is another spot height. There is another spot height which is 997. So these are the different ways in which height is shown on an orthophoto map. That's the way you're supposed to actually take note of how your height is represented or shown on an orthophoto map. Then the other thing that you're also supposed to take note of is how do you interpret your orthophoto map? Okay, how do you come to know that this 6 represent a certain feature, the 9, the 11, the 10, the 8, the 12, and the 7? How do you make sure that you identify the correct features on your orthophoto map? I want to introduce you to something, or I want to make reference to something that is on a topographical map. I want you to make reference to something that is on the topographical map. You can see on the topographical map is written area of the orthophoto map. So you cannot analyze the orthophoto map without making reference to this. This makes your life easier when you are interpreting the orthophoto map, because you can always refer to this red square that is on the topographical map where it's written area of the orthophoto map. This makes your life easier. You can see the blue line here on the area of the orthophoto. If we go to our orthophoto map, you can see there is a river here, which is Clip River. This is the same river that is showing on our topographical map. This is making my life easier. You can also see here in terms of the drainage density that we have here. If you go to your map, you can also see it's even shown on the orthophoto map. Go here, you can see these are built up areas or residential areas where people are staying. If you can come here, you can see their houses here. It's a residential area. So always referring to the square or the area of the orthophoto on the topographical map when you are analyzing your orthophoto map, it makes your life easier, because you'll be able to identify some of the features or landforms that you find on the area of the orthophoto on the topographical map. Then you compare with what you have on an orthophoto map. Okay, so this is your orthophoto map, and this is what is on this orthophoto map. So you should always make reference to this whenever you are analyzing features on an orthophoto map. Make reference to the area of the orthophoto, which is the red square that you find on the topographical map. You can even see, yes, written made in Castle. Come here, you can also see that it's written made in Castle. You can see the steepness of the slope. Here you can see the contours are very close to each other. Same applies here. It's a steep slope. You can see the contours are very close to each other. Come here as well. You can see these are residential areas. If you come here, these are residential areas. They can ask you, what is the name of the residential area? Here you can see it's even written hillside. So it makes it easier now to know, okay, the residential area that is shown on this map on block E5. It means that this is hillside, which is a residential area. So that's how also you do it. Okay, so there are ways in which you can analyze the orthophoto map. I'm going to talk about them now. There are ways in which you can actually use to analyze your orthophoto map. The first one is the shape. You can use the aspect of shape. What do I mean by that? If you look on your orthophoto map, you can see, you can see that the buildings are not of the same size. Some are big, whereas some are small. So when it comes to the shape, okay, you can see, okay, let me say size, not shape. I'll come to shape. Let me start with size. You can also look at the size of the buildings that are on an orthophoto map. You can see these ones are very small, but as you come here, this is big, some are small. So when you look at the buildings where we have got the industrial areas, the buildings are bigger as compared to those areas where they are residential areas. So this can be a residential area, but close to it, you can see this is big. It can be a hospital. It can be also an industrial area. Why? Because of the size of the buildings. So when you're looking now at your orthophoto map, you use the aspect of size. We are saying now some of the buildings are big, especially when it's a residential area. It can be a hospital. The buildings are bigger as compared to the buildings that you find on a residential area. So that's one aspect that you can actually start to use when you are analyzing an orthophoto map. The buildings are very small, they are very close to each other, but if you get to other areas, you can find out that the buildings are very big. It can be an industrial area, it can be a hospital, a shopping center, something like that. So there is difference in terms of the size of the buildings. That helps you to know whether it's a residential area or what type of feature is shown on that orthophoto map. The other thing that you can also use is the shape. Okay, when you look at mostly the constructed features, they've got a regular shape, whereas the natural features, they have got an irregular shape. When you're talking about natural features, you're talking about your rivers, but when you talk about your constructed, you're talking about your buildings. They've got a defined shape. You can see with the way in which they're aligned or designed, you can see this gives you your regular shape. That is part of the constructed features. But when it comes to some of the natural, they've got an irregular shape. So that's what you can also do when you are analyzing your orthophoto map. The other way in which you can analyze is your tone. Okay, when you look at your map, you can see that some of the things appear as dark and some appear as light. So this depends now, especially when you're comparing, let's say, water in a dam and water maybe in a marsh. or of lay area, swampy area, you find that the one in a dam, it might appear to be lighter as compared to the one that is in a mud area or in a marshland. It can be different in terms of coloring, that is the tone. So some can be light and some can be darker. You can see where we have got forest, the areas where you've got forest, you might find that it's a little bit darker as compared to the open areas. You can see this is an open area. You can also see this is an open area. You can see this area is got forest. You can see that's why it's a little bit darker. So that's another way in which you can also use to analyze your orthophoto map. The light, the tone, is it light? Some areas are darker. You can also see in terms of, let's say, you are looking, remember in orthophoto is an image. When you're looking at an image like this, like I've said, some are light and some are dark. So that also helps you in a way. The other way in which you can also analyze your orthophoto is in terms of texture. In terms of texture, when you are looking at an orthophoto, you can see, of course, the roughness, the smoothness. That's what we are referring to. This can be referred to as smooth. Yes, a little bit darker. Roughness also, it can also help you to analyze an orthophoto. We are looking at the texture, that is the roughness or the smoothness, of your features that are on the map. That's what you can also use. So we have said that we can use the size. You can also use the shape, you can also use the tone and this texture. When it comes also to the size, I can also refer to in terms of the height of the buildings. Some buildings can be taller, which means you are likely to see the shadows. Some buildings can be shorter, which means you are likely not to see any shadows. So that can also help you to analyze what is on the orthophoto map. So in short, these are some of the ways in which you can analyze your orthophoto using your size, your shape, your tone, your texture. That's how you can actually analyze the orthophoto. Then the other thing, you need to know that in orthophoto is a large scale map. Large scale map is a large scale map. I'm going to explain this in relation to your topographical map. What do we mean by that? I want you to look at the scale of these two different maps. The smaller the number, the larger the scale. The bigger the number, the smaller the scale, which means your topographical map is a small scale map and your orthophoto map is a large scale map. The smaller the number, the larger the scale. The bigger the number, the smaller the scale. The smaller the number, the larger the scale. The bigger the number, the smaller the scale. We are looking at this number, the relationship between distance on the ground and distance on the actual ground. So this is your large scale map. That's why some features appear to be bigger on an orthophoto map as compared to the topographical map, because it's 5 times larger. It's 5 times larger. That's basically what you're talking about. Where did we get that? Of course, we are using your 1 over 50,000 multiplied by 10,000 over 1. 10,000 over 1. Then this is 5 times larger. That's basically what you're talking about. This is more like your VE, which is your vertical exaggeration. We are comparing the relationship between the two scales. Okay, that is your orthophoto and your topographical map. This is 5 times what? Larger. This is a large scale map. You can see what we mean by when we say what are some of the characteristics of large scale map. It is more detailed. It is for a small area, but it shows more details. That's what it's all about. It's for a small area, but it shows more details. Then for a small scale, like this topographical, it's for a larger area, but it shows what? Less detail. That's the difference between a small scale and large scale map. The other thing that you can also see on your topographical map that I want to talk about is your map code. That is at the top there, is your map code. You can see it's written 2829 dB. 2829 dB. I'm going to explain what it means and what this letter stands for, 2829 dB. So when it comes to maps in South Africa, what is done is, this is your grid, the grid size, okay, this is 28, okay, this is 29 here, okay, I'm going to put this as 29 here, it's fine. This is in terms of degrees. I'm going to put this one, I'm going to put it as 30, okay. So what happens is, this is 30, this is 29 degrees. So this 28, it represents your latitude. This 29 represents your longitude. So each grid square, here the difference is 1 degree. Same applies here, the difference is 1 degree. Okay, so what they do is they divide the whole block into 4 bigger blocks. That is A, B, C, and D. That's what they do when they are doing map coding, map referencing. So they've divided the whole block 28, 29. This is in terms of latitude. 29, 30. This is in terms of longitude. So they divide the whole block into 4 bigger blocks. That is A, B, C, and D. But they further divide it again into 4 blocks, which means each one big block is further divided into 4 bigger blocks. That gives us A, B, C, and D. 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 So this is what we have now. So if you want to understand now what we have here, which is 28, 29 dB, we are saying now this is our latitude. This refers to our latitude. 28 stands for our latitude. Okay, stands for our latitude. 29 our longitude. D is the bigger block, which is A, B, C, and D, which means D is referring to the wall of this bigger block. Then the B. The B now is what we have here. So the map that is shown here, that's why they say an extract, which means it was taken from a bigger map. An extract, it was taken from a bigger map. So the area that we are concentrating on now, that is shown there, is this. This is the area that we are concentrating on. That is your 28, 29 dB. That is the area that we are concentrating is. That's what is shown here as an extract of 29 dB. Okay, that's what we are concentrating on. So just to sum it up, what we have looked at in as far as this lesson is concerned is we have looked at the 3 types of aerial photographs. That is your vertical aerial photograph, your oblique aerial photograph, and your horizontal aerial photograph. Okay, so vertical aerial photograph is taken from 90 degrees from the vertical, which means from an aircraft or from an aeroplane, or it can be a satellite image, which means you are taking what lies beneath. Is more like a top view. You are taking what is on the earth's surface, but from 90 degrees from the vertical. So that is your aerial, vertical aerial photograph. Then when you talk about an oblique simply means at an angle, which means you are taking the photograph at a certain angle from the horizon. That is high oblique at 60 degrees and low oblique at 30 degrees. Those are the 2 types of aerial photographs that are falls under oblique. Then you've got horizontal, which means you're taking from the earth's surface. So when you look at our orthophoto now, it's a combination of aerial, especially vertical aerial photograph, and topographical map. That's what makes up our orthophoto map. So this is done through the process of GIS that is called data layering, which means they put information on top of each other. It starts off as an image. Then on top of that image, what do? They put the topography, that is part of our landscape or relief, which shows the contours, the spot heights, all those things. They are put on top of an image that is an vertical aerial photograph. Then after that, you can also see that the part of our drainage, which is the rivers, the drainage system, is also put on top of that. We have got the residential areas, so it means information is put on top of each other. This is how we come up with the orthophoto map, because it is done or processed through the process of data layering. That's how we come with an orthophoto map. When we have got our orthophoto map now, what is important now is how do you interpret, how do you identify some of these features on an orthophoto map? That's where I say that you have to come to a topographical map where it's written area of the orthophoto map. This makes your life easier. Why am I saying this makes your life easier? Because everything that is here within or inside this box is what is shown on an orthophoto map. So whenever you don't have any clue as to what features are on the orthophoto map, always refer to the area of the orthophoto, because this is where all the features, or this is the area that is covered by the orthophoto map. You can always make reference to this, compare with what is on the area of the orthophoto. When it comes to your area, the orthophoto interpretation or map reading, you can make use of the shape. Okay, we are looking now at the shape. Okay, we are looking at, when we look at the features that are on an orthophoto map, what shape do they have? You'll find that the natural features, they've got an irregular feature shape, whereas the constructed or man-made features, they have a regular shape. You can take an example of this residential area. Then you look at the natural features, the shape that they are assuming, they're irregular as compared to the shape that is assumed by the constructed features. When it comes also to the other aspect of size, we are saying now, where you have got factories, you'll find that the buildings are bigger as compared to those areas where you've got residential areas. So this helps you also to analyze. We also talked about the issue of the tone. We are saying that we are comparing the light colored and the dark colored. The open spaces you can see is light colored, open spaces. When it comes also to the areas that have got forest or that are under the natural forest or forest in general, you can see they're a little bit darker. If you compare also where you've got dams, of course, and compared to area where you've got marshlands, we've got mud water, due to reflection. If you can go to areas where the dam is lighter, but if you go to areas that are muddy, maze, or areas, they are a little bit darker. So the dark also, the tone, darkness or lightness can also help you to analyze the orthophoto map. The texture, we are referring to the roughness. When you feel the orthophoto map, this is fine as compared to the darker part, which can also be a little bit rough, that part of your texture. We have also said that you can look also at the size of the buildings. You can see the taller buildings, you can also, they cast a shadow. You can see the shadow, which resembles that the buildings are taller. But when you look at this short or smaller building, you can see that they do not have any shadows with them. So also another thing, your scale, I've talked about it, how you can convert it from 1:10,000, 1:100 meters to 0.1 kilometers. You have to also familiarize yourself with that. How is also the height shown on the orthophoto map? We have said that we can make use of the contour lines. You can see here is 1090. There's a contour interval of 5 meters from 1090 to 1085. So this shows height on an orthophoto map. We have talked about the spot height. As you can see, this is 999.999. You can also see this one is 1.1092. That also shows you the height above sea level. But the only another thing that you need also to make reference to is when you are looking at all these features, what is the relationship between what you have? What are some of the reasons behind the citation of this can be a residential area? Why is it located there? So there should be a relationship. So when you look at it, you can see that here is steeper. But where you've got residential areas, you can see that the contour lines are far away from each other, which shows that it's gentle. That's why you see we've got residential. The people were able also to build on this land because it's flat, because it's gentle. The contour lines are far away from each other. If you can come and see here, you can see that there is a river here. There is a river, which is Clip River. And if you look at in terms of the number of buildings that are close to the river, you can see they are further away from the river. Why? It can be because they are trying to protect themselves from floods. When the river, when we are receiving rainfall, there can also be floods. Hence, you can see the residential areas are far away from the Clip River. What else can you talk about? You can also see that there is a line of trees along the Clip River. It can also be used as a way of buffering, okay, to protect maybe the buffering, okay, which is demarcating an area, maybe from erosion and other things that can take place. So there's buffering, you are demarcating an area or an object, feature, demarcating around a feature, okay. It can be to control erosion, maybe pollution and things like that. You can see the darker part that we have along Clip River. It can also show you that there is a row of trees. If you can come to topographical map, you can see also there's a row of trees that is along Clip River, which can also be part of buffering. What else can you see there? You can also see when it comes to processes like maybe fluvial geomorphology. I think you have got your Clip River. You can see where inner bank, where there is more deposition taking place, the outer bank, where there's more erosion taking place. I think those are some of the things that you can actually explore, but it's very easy for you to understand if you know the concept now. Now we are linking what we have learned from the topics that we are covering, be it in grade 11, be it in grade 12, grade 10. But now here, when you have got all this information, it makes your life easier because you are able to interpret, to know how to relate your information that are coming from a topic to the map that we have. Boys and girls, that is all about Orthophoto Map. I'm signing up. Ta-da!